Welcome back, dear ladies and gentlemen. After this interesting keynote by Emanuela Andreani, we are back with the new and exciting topic. This time, we speak about the smart and human factory. You might ask yourself, what is the smart and human factory? Well, it is a system of automated, modular, high configurable cells that can be arranged in different ways to meet different requirements. In these cells, you'll find our processing machines, you'll find articulated industrial robots, and AMR self-driving shuttles. Not only do these cells increase efficiency, they also bring along a new kind of interaction between human being, between machine, and robots, where the robots do not replace the human beings, they rather improve the work of human beings by taking over risky or heavy or repetitive tasks. SCM smart and human factories are scalable up to complete production lines that are able to produce entire living rooms, bathrooms, kitchens, and so on. The smart and human factory was first launched back at the Ligna 2019, and since then it has been implemented several times by leading companies in developed markets like Europe, North America, and China. We are about to see its latest version with a lot of improvements with Giacomo Montanelli and Andrea Vignocchi, product managers at SCM, who are already connected with us. So, good afternoon, Giacomo.
Thank you, Pietro. The model is very simple and combines together the following elements. First of all, we have SCM machines for each function required by the production process. So, for instance, we start from the cutting function, and then we will have the edge bending function, and so on. Then we have supervisor and process optimization software in order to get the best from the facility through a continuous monitoring, making all the machine works always at full load and avoiding bottleneck. Process automation through articulated industrial robots to optimize repetitive tasks, but also in order to determine fixed cycle time for loading and offloading operation. Then we have flexible intra-process logistics through self-guided shuttle, easy to use human-machine interface which have been unified across all the SCM technology in order to make easier and quicker the interaction between the man and the machine and improve also the user experience. Internet of Things platform to collect information about the actual use of the facility, improve the availability and reduce the downtime. And last, integration between upstream software like the ERP or MES with the machine through a standardized protocol OPC way to guarantee a common language for all the machine. The end result is a production system with a high level of both horizontal and vertical integration, in which the resources are optimized, reducing the wastage, and the operator, even more important, is deployed in more qualifying tasks. Everything is then organized in simple cell system, which provide you the maximum flexibility and scalability of the production process, so that in case it can be easily adapted to the fast evolution of the market. Moreover, the system we are going to find out during this demonstration is characterized by the capability to combine together in a single solution mass production thanks to the book cutting on the panel saw, and mass customization thanks to the single sheet cutting on the nesting, to preserve the surface finish of the delicate materials, and also to automatically collect and manage both the small as well as the big production offcuts, increasing in this way the overall efficiency. But let's now check it out. The cabinet production process starts into the cutting cell, in which you can see right now the operator that is carrying out on the human-machine interface the launch of the orders that have been received from the ERP systems. They have been processed in order to get the parts list to be produced, and then processed again by the cutting optimizer, which basically match the available in-stock materials with the related cutting patterns. The human-machine interface in overlay does act also as a cell supervisor, which means that it allows to centralize and simplify the control and the monitoring of all the activities within the cutting cell, as well as the machine states. But so let's have a look closer at the machine within this cell. First of all, we have the Flexor HP. This is where the process begins. The automatic board storage flagship of the Flexor range. This is the right choice in case of high productivity, up to 500 cycles per shift, thanks to the axis high performance, which make it particularly suitable in case we have to feed in parallel several machines. And this is even more true in case we have a very extended length of the storage, which can benefit from the high cross beam speed. You can see his pickup device, which is able to adjust itself to a large spectrum of available size on the market, up to a maximum of 5.6 meters length. The detachment of the panel is also facilitated by a specific device mounted on the pickup frame. And during the lift-up phase, there are some sensors that are detecting the boards in order to increase the overall the overall accuracy of the systems, as well as to double-check the panel dimension. Last but not least, thanks to the modular design and the increased maximum stack height up to 2.5 meters inside the storage, the available room in any customer facility will be always optimized. Okay? Inside the storage area, we also find a double position automatic labeling system. This does represent a really key feature for this kind of production model, because first of all, thanks to the label applied on the panel, we are able to track it along the process. But even more important, we are able to recall the specific machining program on each process stage by collecting the information through the use of a specific barcode reader that will be mounted on each machine, as we will see later on. The system is also able to rotate the label before the application, which, combined with the rotation of the pickup frame of the storage, will guarantee always the right direction, the right orientation of the boards on the operating machine. Meanwhile, the white boards are labeled and then placed on the back of the beam saw. We can see on the other side of the cell an articulated industrial robot that has picked up a production offcuts that has been produced from the previous working cycle, and we will see it loading on the nesting machine. Okay? These offcuts have been produced during the previous working cycle, as I have said, and have been temporarily placed on an external rack, which is here represented by a bench next to the robot in a simplified way, available to be used in the next job. The CNC in this case is a Morbidelli X200, which is fitted with a multifunction working table divided into several zones, which are activated according to the board dimension to be processed in order to avoid any vacuum losses. Moreover, during the machining process, it's also possible always to have the maximum grip thanks to the dynamic vacuum functionality that we call on this machine X vacuum, which allow the maximum vacuum concentration in the area in which the router is working, and therefore in the area in which there are the highest force at play. The CNC has performed the cut of 2 finished panels that will be collected by the robot and palletized on a self-driving shuttle awaiting inside the cell. So thanks to the use of the offcuts, basically, we have optimized the available input resources. But let's now move on the other side of the cell, and let me highlight that the cutting combining the panel saw Gabbiani P80 together with the nesting Morbidelli X200 guarantee on one hand flexibility and on the other one productivity, thanks to the possibility to perform the book cutting on the Gabbiani P80 panel saw. This is the brand new horizontal panel saw from SCM for the customer who wants easy, fast and flexible machine, and SCM has improved it in every part. It has been increased on this machine, the saw blade projection, the exhaust outlets, the axis speed, as well as the motor power. The carriage on this machine can also guarantee always excellent finish and precision even at speed, reaching 120 meters per minute in the return. The side alignment device allows always the perfect grip of the pieces, also during the rear trim cut. And thanks to the saw set, the tool change has never been so fast and easy in order to increase the productivity of the machine. Here we can also have a look to the Maestro Active, which is the new human-machine interface, which has been unified across all the SCM technologies in order to make easier and quicker the interaction between operator and machine. And the operator can also have a look on what's happening on the back of the machine, thanks to a smart camera that has been placed on the back of the machine. Moreover, from this interface, we can also have a look to the information that we can get from the Internet of Things platform Maestro Connect that allow a continuous monitoring of the process, increasing the availability and advancing any maintenance need. But let's now move back on the nesting side, that is completing the cutting of the white panel, as you see. And once the cutting of the white panel will be completed, again, we will see the articulated industrial robot collecting the pieces and dropping them onto the shuttle, directly from the working table of the machine. Also in this case, the aim is to avoid the sliding of the panels on the belt conveyor during the offloading operation. But obviously, any anti-scratch materials could have been also offloaded through this way. I forgot to say that also on the panel saw, we have Bristol wheels on the back in order to avoid the sliding of the delicate material, because this is a really key features of this kind of production process that we find both on the panel saw as well as on the nesting machine. Meanwhile, the CNC is concluding the cutting. We can see that the flexor has already prepared in advance and labeled the blue panel on the automatic labeling system. That is possible because the self-supervisor works on a multitask platform that allows to manage in parallel several operations according to their priority, obviously. Typically, the highest priority is always to feed the operating machine in order to maximize the productivity of the systems. But this functionality, let me say that is very useful also in case we have mixed stack into the storage, which means, in other words, that we need to sort the material before feed the operating machine, allowing to save some time using the idle time of the warehouse to prepare in advance all the material that will be needed in the next cutting cycle. We can see right now the robot that is gonna collect once again the pieces from the working table of the machine, and it keeps on staking the pieces on the self-driving shuttle that is awaiting there. But now, meanwhile the robot is completing this phase, I want to put your focus on the position of the nesting machine inside the warehouse. As you can see, the nesting X200 is embedded in the working area of the storage. No? That's allowed the storage, as we will see in a while, to directly load the blue panel on the working table of the CNC, instead of using a traditional powered roller conveyor on the back of the machine. Again, maybe you got now, also in this case, the aim is to avoid the sliding of the delicate material during the loading phases in order to preserve the original surface finish, like we have seen on the panel saw, thanks to the Bristol wheels on the back. However, let me say that this layout configuration can be also very useful in case there is a limited space in any production plant, because of course allow the customer to save the available room, but of course is also slightly affecting the storage capacity. We will see in a while the flexor loading the blue panel onto the working table of the nesting, and this will be cutted by the nesting machine. We already talked about the dynamic vacuum functionality as well as the multifunction working table, but that's not all. As you will see, This machining center will allow you to increase your productivity thanks to the possibility to reach up to 50 meters during the routing function, as we will see in a while. The router working. And moreover, beside the routing function, there are also some drilling heads with the raw X technology capable to reach speeds up to 8,000 RPM, which provide you basically higher accuracy, higher finishing quality, and also higher feed rate. Last but not least, we also can see on this machine a numerically controlled outfeed pusher, which allows first the suction and the cleaning of the pieces that have been cutted before they are offloaded by the robot, and after that also the suction and the cleaning of the machine working table before a new panel is loaded on it. Meanwhile, the CNC is completing the cutting of the blue panel. We can move on this side of the cell, and we will see again in a while the robot collecting the pieces that have been cutted by the nesting machine. This time we have two finished pieces that will be stacked again on the self-driving vehicle, and we will have also in this case, like we already had in the beginning of the production process, a production offcuts. These offcuts will be once again temporarily placed on the external rack, available to be used in the next jobs, like we have seen in the beginning of this demonstration. Okay, so we can say that the cell supervisor is basically able to manage both the small and the big offcuts using alternatively the flextor rather than the robot to handle and feed the operating machine. Okay, and therefore we can state that the articulated robot is not just a simple machine optional replacing the operator. Okay, but I would say on the contrary that it's an integral component which increases the cutting cell functionality. Well, the cutting cycle is almost over, so we are ready to move towards the next process stage, which is the edge bending. And as you can see, the process logistics is carried out by this new generation of self-driving shuttle, which provide a high level of flexibility thanks to the fact they don't need any works on the facility, and so it's very easy to adjust if needed the routes, the path, and consequently the process by simply acting on the HMI of the systems. Moreover, according to the Industry 4.0 principle of man-machine cooperation, this machine can safely travel around people and obstacles, and they are always able to find the shortest way to reach the final destination thanks to a dynamic mapping systems according to the surrounding scenario. But now it's time to move towards the edge bending because the cutting cycle is over. Thank you. So, we are going to see now displayed on your screen the production system layout showing all the manufacturing cells involved into this demonstration. We are going towards the next destination of the shuttle. On board, we have all the panels that have been produced in the previous working cycle. And as we approach the edge bending cell, we can see the shuttle going through a gate in which there are some sensors which are able to recognize the shuttle in order to avoid the emergency stop of the cell. Here we can find the Stephanie Cell E, which is the new flexible edge bending cell, which combines together the advantages of customized and also high volume production, together with a compact design, and even more important, it's affordable also by the small and medium-sized company. It is based on a Stephanie XD, fitted with 6 edge exchanger, which can guarantee a quick edge changes according to the batch processing requirements. And furthermore, is fitted with the RoboLoop kit, which basically allow the automatic loading and offloading of the panels through, once again, an articulated industrial robot, as we can see right now during the loading phase. The robot is aware about the stack's composition, thanks to in terms of size and quantities of the panel, thanks to the communication with the cell supervisor. But however, we also have on his gripper some sensor double-checking the part presence. In this case, you can see the robot that simply has to drop the panel on the XC feeder device, which allow basically to improve the productivity of the robot and consequently also the productivity of the cell, because it allows to introduce the panels directly into the edge bender. And without this device, the robot would have had to guide the panel into the edge bender until the chain of the machine had gripped the pieces, with a consequent bad impact on the productivity of the system. Therefore, we can state that the combination of the robot together with the XC device does represent a smart choice, whether the aim is to maximize the productivity. We already talked in the beginning of this demonstration about how much is important the barcode applied on each panel, so much that I could even call it the panel identity card. And well, in this case, we can see the usefulness of this element. In fact, it's thanks to the information collected by the barcode reader mounted on the gantry above the XC feeder device, which the machine is automatically able to adjust itself to the next job without any intervention of the operator. Each panel is therefore automatically associated to the specific machining programs in terms of edge, color, and thickness, with the subsequent setup of each operating unit of the machine. This happens thanks to the fast axis, which are able to set up each operating unit very quickly, again increasing the productivity of the system. In order to complete the edge bending operation on all the sides of the panel on which is required by the process, obviously the panel need to be returned back once each side has been done. To do that, we have integrated into the cell the new pick-back gantry, which is able basically to manage all the different sides of the panel, picking and dropping them on the belt conveyor on the side of the edge bender machine. The belt conveyor then will return back the panel in a preset position, in which the robot will collect the pieces and will feed again into the machine all the time required by the working cycle. Again, also in this case, it's thanks to the barcode applied on each panel that the machine is able to automatically switch from the longitudinal to the cross direction. Meanwhile, we are looking at the operation of edge bending. Let me highlight also a couple of nice features of this machine. First of all, we have the ability to work even in open loop, which means, in other words, that if we are machining a series of panels, we can introduce a new panel without having to wait the completion of the work in progress. Then we have what we have called Edge Store Manager. Again, also in this case, thanks to another label that this time is applied on the edge roll, it's very easy and quick to change any edge roll if it's needed, because the operator just needs to scan the label on the edge roll to automatically associate the edge roll to the specific machining program. And in this way, all the information about the edge roll that we have just uploaded into the machine are collected and displayed by the human machine interface. As soon as the edge bender will have accomplished the edge bending operation, the panel will be collected once again by the robot, similarly to what we have seen in the previous working area, in the cutting working area, and will be dropped, stacked again on the self-driving vehicle. In the meantime, we can have a process overview through the Maestro Connect dashboard on the process. Here you can see all the information about the process are collected and displayed to the operator. which can also access to this dashboard by using also a remote device, like for instance, a smart device like a tablet or a smartphone. And you can see how each machine state is tracked along the timeline, distinguished between the working time, the idle time, and also on the stopping time. Then, if we need to go deeper on the detail of a specific machine involved into the production process, like for instance the Gabbiani P80 that we have seen in the previous working stage, we can click on the button to access to all the production parameter. And here we can double check, for instance, the last programs that has been executed, as well as the availability, the efficiency of the machine, and of course, all the history of the alarms and the warnings on the machine. The edge bending has been completed now, and theoretically speaking, the next cabin and production process stage would be the drilling and probably also the hardware insertion. But, by the way, these stages won't be displayed during this demonstration. So we will skip these phases, and we will move directly on the end of the line, where we will see basically the manufacturing of the packaging for the assembly kit. I'm going to stop here, and I'm leaving the floor to my colleague Andrea Vignocchi, who will explain deeper this process stage. But I will be once again available in a few minutes in the studio at your disposal to answer to any of your questions. Thank you so much for your attention, and see you later.
Thanks, Giacomo. So, the days of tape, knives, and cardboard package that doesn't fit are over. Now, packaging is made to measure and automatically close at the same time. This revolution is achieved thanks to the combination of the two machines that I will now show you. I'm standing in front of the CUT C200, the cardboard box cutting machine, which in conjunction with the automatic side sealer PAC C100, a combination arranged in cells and conceived to save as much space as possible. CUT C200 and PAC C100 combined to make the innovative packaging solution by SCM. So, thanks to a user-friendly HMI, the operator can enter the product's dimensions on the keyboard or through scanning a barcode on a label. And last but not least, for complete lines, a 3D photocell reader station is used to automatically give the CUT C200 the dimension of the product. The machine is equipped with 6 cutting and crazing tools, and every tool has a single servo motor. So the cardboard is automatically fed, and every package can be customized to measure. Actually, statistical tests shows that 30% of each package sent in Europe is nothing but fresh air. So 30% less volumes means 20% less material. This means 9.9 million trees that could be saved, or 144 million fuel trucks on the road all over the world. This is the ecological aspect to sustain this technology. So hundreds of different cardboard box shapes, as called the FEFCO standards, can be obtained with the CUT C100 in order to optimize every single package needed in production flow for a pure batch one production. This version of our machine is composed, as said, with 6 longitudinal plus 1 transversal cutting and crazing unit. All these groups are independent in order to give the maximum flexible productivity achievable. Thanks to the through cut, I mean the cut through the carton thickness, the product is well shaped and without burrs. And the thickness of the cardboard is not a matter, since every unit has a pneumatic tool which controls the pressure of the unit according to the thickness of the cardboard. So this cardboard thickness can go from 2.5 millimeters up to 8 millimeters. And the CUT C200 can be equipped with multiple cardboard feeder in the back of the machine in order to reduce as much as possible the cardboard scraps. The machine will automatically get the right cardboard width according to the dimension of the box requested. And last but not least, the cardboard can be, of course, printed with the logo of the company. And now, let's follow me, and we go into the PAC-C 100 to see the second part of this process. So, once the box is ready, the second machine, PAC-C 100, will automatically seal the box by means of hot melt glue in order to get the best quality result in the package. PAC-C 100 has an automatic three-dimensional measurement system. This allows an high output volumes, even with batch 1 production. That is, with product of variable size and no presetting at all of the machine. Both single or stacked panel box can be sealed in the PAC-C 100, and the box can be closed with 1 or 2 hot melt glue lines. Conveyors and side aligners are driven by means of servo motors to ensure maximum speed and precision in execution. An average of 8 boxes per minute can be reached depending on production flow. This solution is the best for customers who are delivering knockdown furniture, which is becoming more and more popular in the furniture market. So, as we can see, the box is geometrically perfect, fulfilled, with no extra spaces at all. Very good. And now all the packages are ready to go into the storaging area, where we can offer as well some automated solution by SCM. And now I'm done. I give the word to the studio.
Thank you very much, Andrea, and welcome to the studio, Giacomo.
Good.
So we have just seen that he has sent the robot, so he's on his way to us, and while we're waiting for the robot, I was just wondering, what do you call those robots? Have they got nicknames?
No, not really. Generically speaking, they call it AMR, which is the acronym for Autonomous Mobile Robot.
So no Ricky or Bobby or Robbie or something?
No, but you can call it whatever you want. I mean,
Okay.
yeah.
All right, okay, good. So I know, or I've heard, that these robots can do quite a lot of stuff.
Yeah, it is.
So I was wondering, do they bring coffee too sometimes?
Unfortunately not, Pietro. In this case, the shuttle is going to bring us the assembly kit, including the panel, which have been produced during our demonstration.
Oh, and here he comes.
But you know, your example is suitable because this shuttle belongs to the family of the collaborative robots. And there are several examples of collaborative robots used for serve cocktails to the people rather than coffee as well. So your example is suitable. I would like to highlight that this kind of product, this shuttle, has been used during the pandemic to sanitize all the environment outside the industrial environment, in the healthcare, in the hospital, replacing the operator, so in dangerous activities, risky for their health.
So this is a further proof that the crisis always bears opportunities inside. In this case, it's a useful and, I would say, beautiful opportunity too. So during your presentations, we've received a couple of questions from our viewers, which I would like you to answer.
Yeah.
If you're ready, you are?
Sure.
Good.
I am.
So does this system also manage logistics in the factory, so the whole system?
Absolutely, yes. That's an interesting question. Good question. Because the aim of our demonstration was to show properly this aspect, the logistics management. Actually, we realized that our customer needs changed compared to 10, 15 years ago. Because actually, we moved from a push production model in which the request, the demand was mainly for high productivity, to a pull production model, due to the fact that the end consumer wants to customize as much as possible their own furniture. And due to that, our customers are asking now us for increased flexibility and logistics optimization. Flexibility to have a production process that can be reconfigured according to the fast evolution of the markets, right? And logistics, because you know, now in the facility, due to this high customization, we have, it's plenty of different parts spread around the facility. And I have been several times in the facility. I have seen operators with the tape, double-checking, looking for the pieces. So, of course, flexibility and logistics are basic pillars for profitable business. Automation through robots, self-driving shuttle like this, okay? And of course, all controlled and monitored by supervisor software and process optimization software can make it happen, basically, okay? All parts are always tracked along the process, not only on the operating machine, also in between two different process stages, okay? So basically, I'm talking about a new industrial method in which materials and resources are optimized, okay? And even more important, our customer that has to change his mind, that is change the approach in the way he faces the production, has to know that it can be implemented step by step with a low complexity management and with a reasonable return on investment.
Okay. Speaking of investment, next question. Have you estimated what the approximate payback period of the cutting cell you have shown? So
yeah,
probably
I mean,
ROI, right?
We did some estimation, but let me say that it strongly depends on the way the customer used to work and on the production mix. Let me explain a little bit better. I'm referring to the fact that we have shown a production system able to manage also delicate materials. Of course, this functionality make, let's say, a slight decrease in productivity on the nesting, but not for the nesting itself. It's related to the way we load the nesting and offload, because, I mean, to take care about the delicate material, we avoid the sliding on the rollers in the loading phase, because we load the panel directly with the pickup frame of the flexor on the nesting. And even more important, once the machining is completed, we offload the panel with the robot, piece by piece, instead of using the belt conveyor, because in this way we avoid the sliding of the pieces on the chips, okay? So due to this kind of functionality, basically the nesting productivity is slightly decreased compared to a traditional solution in which we have to process anti-scratch materials. But if we do some assumptions, for instance, that the production mix is composed by 50% by delicate materials and 50% by anti-scratch material, let me say, well, in this case, we can get a good productivity also from the nesting. And we can get, let me say, 500 pieces per shift from the nesting. And on the panel saw, if we work in batch one, we can get 600 panel per shift. If we work with bigger batches, we can reach higher productivity, up to 1,000 pieces per shift. Therefore, the overall productivity of the wall cutting cell is in between 1,000 and 1,500 pieces per shift. Well, this figure now, related to the budgetary investment that the customer has to face in the beginning, that it's about 800,000 euros, give us payback period more or less in between 2 or 3 years. But be careful, because this is just working on one shift. But let me say that since on this cutting cell we have massive automation, it does make more sense to work on multiple shifts, at least 2 or even 3 shifts. In this way, of course, we will have some higher operating costs, labor costs, but the payback will improve, will be better, will be maybe lower than 2 years.
Okay, thank you very much. So how many operators are needed on the cutting and edge bending cell?
Another interesting question. You know, on the cutting cell, of course, we need an operator in front of the panel saw in order to carry out the operation of cutting on the panel saw, even if the panel saw is loaded automatically by the flex store. On the other end, on the nesting machine, we can say that it's fully autonomous because it's loaded by the flex store and the robot. It's offloaded by the robot, and the stacks in and out are managed by the shuttle. So, theoretically speaking, is a fully autonomous cell, the nesting one. Let me say that, of course, the operator on the panel saw sometimes will look also on what's happening on the nesting side, like a supervisor, just sometimes. So we will need one operator on the cutting cell, and moving to the edge banding is the same situation that we have on the nesting, because again, the stacks in and out are managed by the self-driving vehicle, okay? The robots is in charge of loading and offloading. The edge changes is done automatically by the machine without the intervention of any operator. So again, also in this case, theoretically speaking, we would have just we would have no operators. We will need just one supervisor, but not 100% addressed to the edge banding cell. Will be an operator that will be shared among all the cells in that area. So basically, as I said during the demonstration, in this production system, the operator is deployed in more qualifying tasks. In other words, it becomes the director, the mind of the manufacturing systems. And this is the reason why we also need a higher level of qualification. And due to that, I mean, I don't know if you already know it, but SCM has set up a campus structure in order to train this new trade of operators of the factory of the future.
Okay, so one supervisor, to make it short.
Exactly.
Question number 4, how many square meters are needed for the cells?
Well,
for those we have seen in the show,
if we refer to the cutting cell, so we have the Flexor HP, 12 by 12 meters. We have the nesting machine, the X200, that, by the way, is embedded into the warehouse area, which means that we can save space thanks to that. We have the panel saw, Gabbiani P80, and the robot. All that, let me say, that needs more or less 250 square meters. But let me also highlight that due to the demonstration purposes, the Flexor has been reduced because I would expect in the reality to have a bigger storage, okay? And this is in order to guarantee an higher autonomy to the operating machine. Otherwise, we will have to refill continuously the storage, okay? So I would expect at least to have 12 by 24 meter upwards. In this case, the floor occupancy is about 400 square meters, okay? Moving on the edge banding side, well, we have the Stephanie XD, the RoboLoop kit, the XC feeding device, and the pick-back gantry. All these needs more or less 180 square meters. So let me say that it's pretty compact, as I said during my presentation.
Okay, question number 5. Which are the maximum and minimum dimensions of the offcuts we can manage in the cutting cell?
Well, I'm very pleased that we get this question, because once again, I can highlight one of the purposes of this demonstration. One of the purposes of this demonstration, in fact, was to, we stressed a lot the material optimization concept, okay? And this is thanks also to reuse of the production offcuts, okay? By the way, the Flexor pickup frame that is composed by some vacuum caps can manage, by deactivating some of them, the smaller pieces that it can manage are about 1,800 millimeters as minimum length and 400 millimeters as minimum width, okay? But thanks to the integration of the robots, that in this way is not just an optional, is an integral component of the cell, because, extend the range of pieces that can be managed. Thanks to the integration with the robot, we are able to manage smaller pieces up to a minimum dimension about 250 millimeters by 180 millimeters. So we really increased the production cell capabilities in this way, okay? I'm not really concerned, on the other end, about the maximum dimension, because on the Flexor we have a pickup frame that is able to manage up to 5.6 meters maximum length, 2.2 meters maximum width. So any offcuts within this range can be managed by the Flexor. As well as on the robot, we have the maximum dimension, 3,000 millimeters length and 1,200 millimeters width. So any offcuts in this range can be managed by, alternatively, the Flexor or the robot.
Okay. Last question. You mentioned that it is possible to manage delicate materials. What do you mean by that?
Yeah. Basically, I do mean that since we are loading on the panel, so we have the Bristol wheels on the back, okay? We are loading the nesting directly on the working table, so avoiding the sliding of the material, as I said a few minutes ago, in the feeding phase. And we offload the panels from the nesting through the robots, so avoiding the sliding of the pieces on the belt conveyor, maybe in presence of also of chips. Basically, what I mean is that we are not going to alter the surface finish of the income material, of the inbound materials. And it is not referring specifically to a material, but let me say that a typical example could be the glossy PVC panel with or without the protective film.
Okay, well, unfortunately, that's all we have got time for in this session, so I would like to say thank you to my human guest, Giacomo, and